Hey y'all, see a lot of people here. I'm sorry, I'm laughing because I dared to read the chat before I came in. And I probably shouldn't have done that because then I wouldn't have seen the joke that Mikey put up there. That was really gross, but wonderful. Oh, goodness. I guess if Mikey likes it. Is anyone old enough to remember that commercial? Hey, he didn't need it. Give it to Mikey. He likes everything. Even apparently really bad jokes about mathematicians and pencils. I'll never look at a pencil the same way again. It gives a whole new meaning to the word number two. So that's where they get the number two in the number two pencil, isn't it? Oh, that is so gross. Okay, guys, hi. Hopefully everybody can hear me. I'll try to recompose myself. Let me know if you guys can see me, if you can hear me okay. It looks like everything's working well. And wow, do we have some cool stuff going on. It's been a while since I've done an informal forecast live to the public, but I was requested to do this. Usually I do these behind the scenes for my Patreon community because they can appreciate my wackiness and they don't mind the informality. These informal forecasts aren't nearly as polished as my formal forecasts are. So I'm a lot yeah, I'm just probably a lot sillier than you might realize unless you're part of that community. First thing I have to say thanks to Michael Richardson. I appreciate you being here, Mike. Michael is he's a moderator. If you see Jerry Ryan, he's also a moderator. I don't know if he's going to be able to make it tonight, but thank you, Michael. You're going to make sure that everybody is minding their P's and Q's and being good and being respectful. Jokes notwithstanding. And also this is a big thank you to all my Patreon members because they are the reasons why these forecasts are even possible. So thank you all. I don't know how many people have been paying attention to the sun lately, but it has gotten very busy. And I'm going to try to help unpack all of the craziness that's going on. And if it's any indication, you know, I've been doing this for so long. I don't realize that from one solar minimum to the quiet period in solar minimum up to the rise of the new cycle, how much can change in terms of the community and in terms of different space weather offices, official offices and official sources of space weather information. And the change that has happened from the waning phase of the last solar cycle to the pickup of this solar cycle, there's been a massive amount of change. We now have more institutions than I can count that are actually trying to model solar storms and putting them up on their official websites. And I can just tell this solar cycle is going to be a lot of fun because there's going to be a lot of different answers floating around and trying to figure out which ones are the correct ones and which ones aren't and how off are they. It's definitely going to wake up quite a few people, I think, in the science community as well in the operational community, because it's just crazy, and you'll see some of that tonight. So good. I see people are telling me that they can hear me. Hello, everyone. I see lots of names. This is so great. I'm so glad you're all here. And for those who are Patreon members, if you feel like you're being lost in the chat, post your questions on the Patreon feed that got you here, and and I'll answer the questions there. I mean, I will answer the questions during the live feed, but you have that special access to me. So feel free to ask questions because you guys get priority. But I'm so glad you guys can hear me, and excellent. So good. It sounds like I'm coming through clearly, and you guys, wow, wonderful. Okay. Very exciting catching you live. Oh, good job. I think it's great, Karina. I'm appreciative that you're here. Thanks for coming in. Good evening from Northeast Texas. Thanks, Roger. I appreciate that. Okay, now, oh, wonderful. Lulu's here. That's great. And I think I saw Nick Gaspard might be here, another VIP member. So, and Yardley Bottles. Good to see you guys. Hope you're all doing well. Okay. So let's begin to unpack some of this craziness that's going on. As a matter of fact, I have so much stuff to show you. My computer is actually like bogging down. So if I have to reset or kill a couple of these animations in order to like free up memory in my system, please forgive me. But I'm standing right now in front of the 304 angstrom image of the sun. hopefully you can see the bottom. It's mirrored for me, but hopefully it's not mirrored for you, and you can read the actual dates so you can see what's going on. The reason why I'm showing you 304 angstroms is because, wow, there's been a lot of eye candy, and you just saw a little bit right there. We have filaments galore, and this is a very good sign that solar cycle 25 is picking up. The fact that we have filament channels that are filling up and are being ejected. They're actually not just kind of raining back down into the sun because there's just no oomph. We're actually getting, as you can see from several of them, we're getting some explosive ejections of the filament structures and of deeper parts, deeper material, deeper in the chromosphere, which is really cool. So sadly, though, when we start getting this stuff, when you start getting the more dense material ejected, like we're seeing, that begins to complicate the coronagraph picture. Not just because you have more structures going on, which is of course part of it, but now you're having more dense structures that you can't see through. And you're having stuff coming in and out of the sun, or coming out of the sun rather, that are moving at different speeds. And it becomes a bit difficult to know when something is moving in front of something else. They're both moving, but one's moving faster. How does that look? How do they mesh? What structure belongs to what storm? And with coronagraph observations, it makes it extremely difficult to try to get speed, try to do any analysis that allows you to get speed and direction. Because these are two-dimensional images that are trying to take three-dimensional objects and flatten them into a two-dimensional thing. And you've got to now kind of read through all that mess. So this is why I'm just setting the stage for what you're going to see later, and hopefully give you a little bit of compassion when you see how much space scientists are struggling with this right now. But back on around the 22nd, we were talking about this one filament eruption. Or the filament here, I'm making my screen so I can see what I'm doing. We have this filament that I was talking about in the last, whoops, it just disappeared. Well, I'll wait till it resets. But we have this last filament that was in, if you've watched my most recent forecast, it was just beginning to erupt. Here it is. You can see it here in this reset. Back on like the 22nd and 23rd, it finally erupts very, very slowly on the 23rd. Part of it kind of rains back down, but part of it just kind of slowly lifts off. And we'll see that in coronagraphs. It ends up being this very interesting looking halo, kind of a very wispy-like halo, which is a structure that goes all the way around the sun in coronagraph images. But that filament, which we were watching, was just the beginning of a really cool set of observations. In fact, we actually had one that happened before that. I guess I could back up a little bit further. See what I mean? These are very informal. If we wait for it to reset, there we go. Back on the 22nd, there was actually an eruption that happened down here, and I don't know if we missed it already, but there was a filament eruption that came off of the sun down in the south. Then a little bit later on the same day, let me show you. I have the power. Yes, I do. So let's do this. Okay. So let me get out of the way, and hopefully you can see, here's a filament down here. This is back on the 22nd. See this right in here? And if I rock it, see that thing leaving right there? That's the filament I'm talking about. Okay. So that was a nice little nifty eruption, pretty dense eruption too. We'll see it especially in stereo. Oh my gosh, I'll show you stereo chronographs. It was pretty intense. So it ruptures. It's a not a wide, but a narrow structure, but it leaves on the 22nd early in the morning. This filament at that time, if I can get my hand in the right place, this filament up here, it was still kind of lingering, right? Now, as we proceed through the course of the day, through the end of the 22nd, whoosh, it begins to go away. See how it kind of begins to drain? Kind of like, where'd it go, right? Part of it was being lifted off, part of it was raining back down. And before too long, you can actually barely see in 304 angstroms, you can barely see these really dim brightenings. These are, believe it or not, ribbons, for those of you who know the phrase. So this is actually part of that structure tearing off. See them? Just barely. You can see it better in 211 angstroms, which I'll show you later. Sorry about the flickering. That is either missed imagery or my computer missing the image. We are in eclipse season, by the way, so every now and again the SDO does get eclipsed by the moon. So if you're wondering why your image is missing, the moon is passing between SDO and the sun right now. So so then that was the 22nd. So you get stuff going off on the 22nd, early in the morning, late in the evening, and then into the 23rd, because now we're at the morning of the 23rd, right? So then as you continue moving on, you have this other structure. And I'll try to get in the right place over here. Do you guys see, let me back up. Do you guys see this weird filament thing? Do you see this kind of going off up here? Do you see right there? See that going off? That is yet another filament. And sorry, see this shadow here? That right there? That's the moon. Hello, moon. So this structure goes off, and this structure ended up being pretty dense. And if I pull this down a little bit, maybe you can see we actually had a pretty decent eruption up here, but it gets eclipsed by the moon, so we miss half of it. Look at this right there. See that? Isn't that pretty? Look at that. So the moon stole our view. And I don't have the old SUVI data because SUVI is in a different place. It's on GO, so it may not have been eclipsed at this time. I wish I should go back and look at SUVI images to see if we could actually see the rest of this eruption. But SDO gets eclipsed, so we miss it. But that was a pretty dense filament. So that goes off to the sun's west in coronagraphs. We already have something coming off to the sun's south and to the sun's north, as well as kind of around. And now we have something coming off to the sun's west. And now, just a few hours later, we get this. Look at this monster. Boom. See this guy? This is from region 2860, or 59 rather, sorry, 2859. Looks okay in SDO imagery. Man, you want to see what it looks like in SUVI? Beautiful. Check this out. So I'll leave the timestamp on there for a second so you can see it, and I'll get out of the way. Whoops, I'll stand on this side. Those of you who follow me on Patreon, you've seen this many times, and if you've seen it on Twitter as well, I've posted it on Twitter. Look at this. This is the nice thing about the SUVI instrument, which is made by Lockheed Martin. Same folks that made AIA on the SDO spacecraft. But with SUVI, they made it specifically for operations. So it's got a slightly wider field of view, so it can see a little bit further out. It's got a slightly different observation cadence. I mean, it actually takes pictures faster. And it also has slightly different exposure settings. So you can actually see some of this stuff. So look how amazing this looks like in SUVI, right? So that's what that eruption looked like in for real, which really tells you want to see further out, don't you? You want to be able to come and see what this structure is going to be like. Oops, I should probably, well, I guess I could stand here. And I think some of the next generation observations are going to have structures that come, the instrumentation is going to have views that are clear out here. Boy, that's going to be nice. But that's going to be, another decade or so before we have that likely. But SUVI has really shown us some really nice imagery. And as you can tell from this structure, and that's one of the reasons why it's super important to have SUVI, is that you can tell from this structure, all of that stuff seems to kind of come out from the sun and then wrap around to the east. Do you notice that? It almost looks like it's being tugged. Do you see how it kind of comes out this way like a big... So someone told me it looked like the sun was blowing his nose about it, 2 nostrils. It's pretty funny. So I was just thinking about that joke. This structure comes out and it looks like it's coming out this way, but then it seems to kind of just wrap around like that. And that's probably due to the magnetic field and maybe even the fact that we had a coronal hole up here that is the solar wind is such a way that it's keeping the structure kind of off to the side. So what that means is that we have, by the 22nd, we had something coming to the south of the sun, something coming kind of to the north and around because it was coming much more further out. That was that other filament eruption. Then we had a structure that came off to the west. And now we have this snot-nosed structure coming off to the east. So, I mean, we've hit all 4 corners, right? If you can, got all sides of the compass rose here, and all within about a day or a couple days of each other, from the 22nd to the 24th. Talk about crazy. So I'll just play this again, and we're still having more stuff going on. So as I continue to let it play, we're down the 25th, and we have another filament, which as it resets, I have to wait for it. But we had the first one come off the south, then we had this other structure come off the north, then we had this structure that's coming off to the east over here, and then we have this snot-nosed thing. And I was late every time. I covered it every time. Let's try it one more time. I'll let it go back. Okay, there was the structure down south. Here's the structure bleeding off. Now we have this one coming over here, and then we have this structure about to blow off this way. There we go. So all of that in a very, very short notice, and we have all of this stuff that is trying to be analyzed in, you know, almost sitting on top of each other in a flat two-dimensional, you know, set of images from the LASCO coronagraph. Meanwhile, we also, and it'll probably reset on me again, we have that filament right there, which looks like it's draining off at the moment. Kind of hard to tell. Doesn't look like it's going to erupt. It looks like it'll fall back. So at least for the moment, that may be all we have for eruptions. Let's hope. On top, and so we'll get to the coronagraphs in a minute. Let me just tell you what else is going on the sun really fast. We do have a new region. This is region 2860. It's been growing pretty rapidly, and it is now the main player when it comes to, I'm waiting for it to emerge here. Here it comes. We're looking at it now as being the main potential for M-class flares. It's only got a 5% chance of M-class flares, but we are watching it. There's also another region that could very well get numbered 2861. It is not this. Is it this region? It might be this region. Or is it the one right behind it? Yeah, it's this new guy growing right behind it. There we go. We have yet to really see what's going to happen with that one, but that may be yet a new region. On top of that, we have yet another region that's going to rotate into Earth view here soon. So those of you who are amateur radio operators, you should look at that and see solar flux going up. And yes, we've already gotten into the low 80s for solar flux. So radio propagation on Earth's day side is getting better. So let's switch to 211 angstroms. The reason why I switch here is because I want you to see the coronal holes. Here's a coronal hole. This is a polar coronal hole that we're feeling the influence of right now. That is sending us some fast solar wind right now, not as strong as last rotation. As a matter of fact, pretty weak. We're barely busting about 400 kilometers a second right now. There was some gorgeous aurora. For those of you who follow me on Twitter, there was gorgeous aurora in Manitoba, in North Dakota. I'm trying to think of the places. It was mostly in the Western Hemisphere. I don't think the fast wind got to us fast enough to get us anywhere that was able to get people to see aurora in Europe or in the UK and Scotland, that area. I'm not even sure we saw any in Iceland. It might have been it might have come on too late. But we definitely got some good stuff in Manitoba, in North Dakota, as far south as North Dakota, and somewhere else I don't remember if it was Saskatchewan. I think it might have been Saskatchewan. Might have been Alberta as well. But I have to go back and take a look. But there's definitely some beautiful shots on my Twitter feed. And the smoke is finally clearing, so people are being able to see aurora again, which is nice. But this fast solar wind's going to die down a little bit. Pretty soon we're going to start feeling the influence of these smaller coronal holes. Probably not a super big impact from these, from the fast wind from these, but they will be rotating in through the Earth strike zone right about the same time we're expecting one of those solar storms, the only one that seems to be Earth directed, really Earth directed, to hit us. So it's going to be, it definitely could enhance the solar storm when it hits us, but it's just so hard to tell. Because there's just not going to be a lot of influence. But I just put this up here because I wanted you to see that we do have some fast solar wind involvement as well, and that we are getting aurora right now from the fast solar wind, not from any of the storms that have been launched. They have yet to reach us. Do I want to show this first from Stereo's view, or do I want to show? I'll just show Earth view first. Hold on. So just to kind of highlight that. And then I'll take questions shortly, guys. So this is the magnetic field. This is the HMI instrument aboard SDO. And what you're looking at are what we call HAARPs. No, not HAARP, not that ionospheric heater, but rather active region patches, hemispheric active region patches. And some of them become, well, the reason why I love this particular diagram is because they really show how quickly they grow. So as you can see, these are magnetic active, these are the active regions essentially. Some of them end up getting sunspot numbers, and when they do, you actually see these tiny little numbers, these tiny little yellow numbers. But what's nice is that they've actually got a perimeter around where these patches grow and what their involvement is magnetically. And excuse me, we had, these are the old ones going off from region like 2855 and the ones that we kind of lost just over this past week. But we started getting region 2859. That was the one that did have an M flare, was almost an M flare player, kind of had about 5% chance of being an M flare player about 3 or 4 days ago. That has calmed down a little bit, but that was when that big, I hate to say it, snot nose kind of eruption, that massive eruption that came out of the sun, that was from that region, that blue region. And so we're going to be dealing with that, is definitely boosting the solar flux, and we'll be dealing with that all the way across the Earth-facing disk. I don't think this one's going to die down too much. So we can expect solar flux to stay up. The interesting bit is when we start seeing, I have to wait for it. I probably should make it faster. Okay, so there's region 2859 again growing in the north. Shortly thereafter, you see region 2860 growing. Not yet. Wait for it. Wait for it. That's such a trite thing to say, isn't it? Come on, there you are. Okay, so there's region 2860. You can see it growing quite quickly. It's slowed down a little bit over the past day, but it's still growing reasonably fast. The difference is we're seeing it kind of spread quickly. So that means probably not going to get really big flares from it, but we do still have a small chance of M-class flares. We've been seeing a bit of definitely C-class flares, about I think like a 30% chance of C-class flares. That's going to continue. And even though we're not really seeing the new region yet, the one I talked about, that's not really showing up on this map as of yet. I guess I should probably, let me pause it when we get there. Hold on a sec. I'll scoot it over. I'll wait for region 2860 to come up. Yeah, a little bit further, hold on. So we're seeing, if I stand over here, so there's 2859, 2860. Those are the main players right now on the Earth-facing disk. This is not that new region. This is the kind of the decaying region, which is actually showing a little bit of signs of growth, but I don't think it's going to go anywhere. And we have yet to see anything from that new region that's emerging. But that region, it's because it's moving so fast. It's emerging quite quickly and very bright. I wouldn't be surprised if it ends up growing very much like these other two regions have. So very, very soon we may be up to about an 85 in solar flux on the Earth's day side. Possibly even higher. So we may be creeping up to the 90s, which would be really cool, because then we're beginning to get into the, almost the good range for radio propagation. So even though the bands are noisy, guys, take it, because it's definitely good news. And in that vein, as a matter of fact, I'll go ahead and kill this so that, and I'll kill this too, so that I can show you. Oh, come on, stereo, don't do this to me. Do I need to reload this? The lights are on, but nobody's home. See, this as it's displaying. This is what I mean by memory problems. Come on, stereo, don't do this. Oh, shoot. All right, let me see if I can reload it. Yes, confirm. All right, it's loading again. Sorry, it's going to take a second to load. But yes, my memory and my computer is going, why do you have to give me so much stuff to do? So let's let that load for a sec. And I'll see if anybody has any questions right now for me. How active is the sun? Does the sun trigger earthquakes and volcanoes? Oh my goodness, is that a loaded question? The sun, how active is it right now? It's just beginning to ramp up for solar cycle 25. So it's not... I mean, this is just the beginning. We haven't even begun to see what the sun is going to do this cycle. As far as does it cause earthquakes and volcanoes, there's a lot of people who want to correlate the two. And is there a potential, is there a possibility that there is some influence there? Of course there is. There's a potential for the moon and its tides to cause volcanoes and earthquakes. Because of the tidal forces. The issue that we have, though, is that we can't quantify it, because earthquakes on Earth are driven by they're just driven so often. They happen all the time. They correlate with everything. I mean, as I've made the joke before, I could sneeze right now and there'd be an earthquake somewhere, a big one. And I'd say, oh, well, obviously my sneeze caused that earthquake. And until we're able to back out the primary drivers of earthquakes, which are, the the big forces, the geological forces, the plate tectonics and all of that, then if we can't back out those geophysical drivers and back out that quantitatively, we will never be able to see the underlying forces. So, and understand how much space weather or tidal forces or planetary alignments, affect any type of geological activity on Earth. And it's kind of like, and it's the same thing. I talk about this analogy so often. It's like having a bathtub full of water, and there may be toys in the bottom of the bathtub, but until you drain the water down low enough to be able to see those toys, you don't even know that they're there if the water is murky and soapy. And that's kind of the way, that's really what we're dealing with, is that we can speculate all we want, but we will never be able to quantify it unless we're able to remove quantifiably remove the effect of the primary drivers. So then we can see what's left. What are the toys in the bottom of the bathtub, and be able to assess what those toys are and what they correlate with. So, and we are decades probably off from being able to do that, sadly. And it's not space physics. It's not a space weather problem. It's a geophysics problem, because they really need to be able to figure out how to probe and understand the microphysics that cause earthquakes. And that's not an easy problem. So that's about all I'm going to say about it on this. My friend has a Twitch stream, and would he be able to post your updates for us to view? Yes, except for the Patreon stuff. That's the problem. I've been asked, can people post my courses on their channel? I don't think I'm comfortable with that. The reason why is because I don't own those courses. My Patreon community does. And, I'd have to talk to them about it. So I don't know. Maybe we can try a dialogue. I'd have to talk to my Patreon folks about that and see what they think. If they're willing to share, then yeah, perhaps. But otherwise, it's really for them. And I bow to whatever they want me to do. So hopefully that's a good enough answer for you. Okay, let me get back to this, guys. Yardley, who told her about my bathtub? Yeah, I know. Toys in the bathtub, right? Underneath the soapy water. I have a young daughter, so that's where the bathtub analogy comes in. That's pretty funny, though. Okay, so let me speed this up just a smidge. But it looks like stereo is running now. So this is what's cool. Sadly, we have both beacon data and beacon data and science data in here. If anyone ever wonders, when you look at stereo data, if you ever see people show this on YouTube or wherever, the reason why sometimes the images look really pristine and then they go ratty, like this, these are really pristine images, and then they go ratty. It's not because stereo is an old spacecraft. That has nothing to do with it. It has everything. You see, here's the ratty images now, see? And they rotate faster because there's not as many images. That's because the stuff that we're getting down from stereo that is almost in real time, we call those beacon images. And they are lower resolution, and they're not as high a cadence. And the reason for that is because stereo is been designed to be on the other side of the sun. And so the telemetry stream between Earth and it is very, very small, right? I mean, it's the same reason why SDO, for example, is in geosynchronous orbit and not out at L1 further out, is because its telemetry pipe, its straw that it's, that Earth is sucking data from is very, very big. It has to be, so the spacecraft has to be close to Earth to have such a big straw to give down gigabytes of data a day. Whereas poor stereo, if it gets kilobytes of data down a day, it's lucky. And so beacon data, which is the most recent data, will always be degraded in imagery, in quality, and also in cadence. So once, after a few days, then they're able to get the rest of the data down and get the high quality images down. But prior to that, we deal with degraded images. So that's what you're kind of seeing here, is that you're seeing, like back on the 22nd, we actually have gotten the science grade data down. So you're actually seeing really high quality images. And you can see region 2859 right here. That's this guy. This is a plage region. If I can point it out right here, that one. This back here is also plage. Region 28, whoops, not that, this. Region 2860 actually begins to build just behind this region here. So as it begins to rotate into Earth view. Earth view is sitting somewhere right about in here. I think we've got about 2 or 3 days at this point. Stereo barely sees the backside or the far side compared to us. And you'll see region 2859 very soon start becoming very active. This was on the 23rd. You'll even see that big explosion kind of thing going off. And it's a beautiful eruption. I think it's still in beacon data though, so it'll flip over to RADI images. Yeah, here we go. There's that big eruption going off. And we're seeing a few more things going off here and there, and we're seeing those regions being, excuse me, the region 2860 growing quite quickly. Let me reverse this for a sec and get back to the more recent times. Here we go. I'm continuing to back it up so we can watch this and slow it down. Maybe a little bit faster than that. So, whoops, it's still going backwards. Come on, Tim. Forward, please. Okay, so as you watch this, there is that big eruption going off, and you'll see just behind this region here, there we go, there it is, see it? That's region 2860. But look behind region 2860, that's just beginning to rotate into Earth view now. Okay, you've got another region just behind it, and another region just behind it. So, whoops, before the thing turned and reset, let me reverse. Let's get back to the most recent image. There we go. So this is the most recent image we have. So you can see we really do have quite a few regions that are going to be rotating into Earth view yet. At least 2, maybe 3. Okay, and it looks like there might be a little bit of something on this in the southern hemisphere, but considering the latitude is not that high, it's a pretty low latitude here. And probably not going to be all that much. So we'll have to wait to see if there's any other new regions. But getting up to 90s, the low or the high 80s, low 90s for solar flux over the next maybe week or 3 or 4 days, let's say, at least in the short term, is very possible. So just be aware of that, and that's going to be good news for everyone. And now, let me just play Coronagraph imagery. So this is stereo coronagraph. So this structure that came off, as you can see, really dense structure, that was that eruption that I told you was going off the south. Then, unfortunately, we lose some frames, but you can see on the 23rd, I think, is when you'll see it. It'll start, and you'll see this big structure, and I'll pause it. There we go. Let me pause. Oh, shoot. Not too far. Stop. Reverse. Step. Let me see what time it is. Okay. Let me step back a couple bit more. There we go. So here's the bigger structure. This is that filament eruption, that one that we were talking about during my first forecast. I mean, my most recent formal forecast. This is that filament that was kind of like partly raining down, but also erupting, right? That was this one. Let me get a better picture of it. A little bit earlier on. There we go. And it was still reasonably formed. This guy. Remember this guy back on the 22nd and 23rd? So when this structure erupted in the Earth strike zone, okay, this is what stereo saw in its coronagraph. Okay, Earth is kind of off this away. Okay, not completely straight, but kind of like that. Sorry, I'm getting a notification. I just want to make sure. Oh, good. Okay. Just want to make sure nothing bad had happened. Because sometimes my mic goes out or something weird happens, and Mike will let me know. So we have Earth kind of in this direction here, right? And then this big structure, I don't know if you can tell, but I've kind of talked about it being a smoke ring. And you can kind of see that smoke ring in through here. Do you see this kind of like a ring structure? See if I can kind of make a, there we go, kind of like that. So it's almost like a cone to some degree coming out. And that's important because as you'll see when we look at from Earth, you'll actually see kind of this halo where it looks like something's completely engulfing Earth or engulfing the sun in a sense as it's coming outward from the center area, from the center disk region. you know, from this, but we're going to see it in stereo. I mean, not in stereo, but in LASCO's imagery. So this is from stereo's view. And so you can see this is pretty massive, and it definitely spans both high and lower latitudes. So if Earth is in this Earth-Sun line, that should be in the path, okay? This is not just something that's going straight north. This is something that's going both north and south, and definitely has a possibility of being, just from this view, has a possibility of being Earth-directed. So we continue, whoops, let's not go backwards, let's go forwards. Oh, by the way, same thing with chronograph data. Notice how clean it looks here? But very soon, like if I go to the next frame, if I do a step forward, there, look how ratty. This is beacon data, okay, so degraded. So once again, it's not that stereo's old, it's that this is now beacon data, and it's the best we can do for now. So as we continue moving forward in time, very soon we will see the other eruption. We'll see both two eruptions, I think, one coming off on either side. One of them is the west limb eruption from Earth, and this is the east limb eruption. I'll back it up. This is how complicated things get, guys. Sorry if you're getting a headache from this. But this is, let me do step. This is exactly how complicated space weather can get. Okay, so again, we've lost a few frames, but let me make sure. So we saw the eruption that went south. We saw that big eruption that went north, and that was the big smoke ring thing, okay? Now we're looking at both the eruptions that are going west, which is on this side, and east on this side. And why are you saying, Tamitha, you've got the sides wrong? No, I'm looking at it from stereo's point of view, but I'm using Earth's point of view. So I'm using the labels I would label it from Earth's perspective on stereo's view. So that's kind of confusing in of itself. But if you were to look at these CMEs, these solar storms coming off from Earth's perspective, which we will in just a moment, you will see that this one, this really bright one, this is the one that back in SDO, this guy. See this guy? Oh, we point to the right place. Remember me talking about this coming off of the sun's west limb from Earth's view? Okay, that is, whoops, jumping ahead. That is this. That's this structure, okay? This structure, on the other hand, from stereo's vantage point, is almost a full halo. This is that snot nose stuff that came off. I'm sorry. How else do I describe it? So this is why this structure is almost a smoke ring, almost a full halo for stereo, is because this structure is coming far closer to stereo. It's actually going to probably hit stereo. Whereas at Earth, I think it's going to miss us. And we'll talk about that more in a sec. So that, in a nutshell, is the south, north, west, and east eruptions, all in a very short period of time. And I'll go ahead and play this again faster. So you get to see, and then we still have yet another structure that's coming off after that, but I won't talk about that because it's not anywhere near causing us any problems. So that was the south one. Here's the north one. And you've got the west and east, bang, bang. Okay. And then, like I said, there's this new structure that's beginning to grow off as well. Wow. All right. So this is, sadly, this is what space weather forecasters right now are having to deal with in coronagraph imagery, right? They've got stuff coming off the south, stuff coming off the north, stuff coming off the west and the east. And now they got to piece it together and say, well, what's going to hit Earth and what isn't? Oh boy. You ready to see how fun it gets? This is where it gets really crazy. So before I move to those and show you the models, how well, oh, actually I'll show you my coronagraphs for the coronagraph images for at Earth really fast. So here we go. This is seeds. This is for the, I'm not going to bother showing the south one because it's really kind of irrelevant for us. I'd have to go back to the 22nd to do it, and I don't want to take the time. So what this is now the Earth's view coronagraph. This is LASCO, And the red, if I point in the right place, yes, the red image is the raw image, so the intensity images. The gray is the difference images that highlight the features. And we need that especially because, as you can see, that there's some very wispy features here. Sorry it blinks, but that's part of the, it's just an automated algorithm that doesn't normalize the images very well. So we have to deal with that. It just is the way it is. It's not always that pretty. Okay, so I don't know if you notice this, but if I'll keep it moving for a minute, but every now and again, because this is just playing the 23rd over and over again, you can see the timestamp up in the left corner. You'll see something that looks like a smoke ring. Do you guys see that? I'll let it play one more time and then I will stop it. So there goes the smoke ring in the north and there it goes in the south. Okay, so where's my mouse? Where is my mouse? There it is. Okay, so here's the smoke ring in the north. And anybody who's watched my forecast last time, the formal forecast, knows this is about where the coronagraph images left us when I had to publish the video. So that's about where we were. We were just beginning to see that halo. See it? That little white kind of thing. Really hard to see in the intensity images, though. If you really squint, you might see it, but a lot easier to see in the difference images. Then as we move a little bit out a little bit longer, a little bit further in time, now you're beginning to see it not just up here, and it's much clearer. Whoops, if I can get my hand in the right place. See it all out here, right? See all that? But now look where you're beginning to see it as well. See how the smoke ring is beginning to fill out in this area? It's because it's now getting past that occulting disk, right? It's getting beyond it. It's growing. It's coming out toward you. And as it starts as a small little object, you know, let's say inside this occulting disk, you can't see it. But as it gets closer and closer and closer to the camera, it gets bigger and bigger and bigger and bigger. And see how it's now I'm outside of that occulting disk. And so now you can actually see it. That's why these images, these signatures seem to just emerge out of nowhere, is because the structure is getting bigger and bigger as it's moving outward. It's expanding and it's getting closer to Earth. So it's kind of, you know, two different things that are happening at the same time. But you're seeing, so now you're seeing this as being a partial halo that is extended from the west limb up into the north, right, or really from the north mainly, and then now it's extending west. Okay, and if we go a little bit further out, look. Do you see it now? Now you're beginning to see it getting past that occulting disk in the south as well. And it goes all the way around. If I can get my hand, whoops, not that far out, Tam. So see all this? If I can get my hand in the right place. I know I look like a drunken sailor sometimes. I've got a delay on my green screen thing. So I don't see what I'm doing, but except for 2 seconds after. So hopefully you saw that trace. And it goes all the way around. So let me just play it again. It's a lot easier to see it when it moves than when it stays still. So hopefully you can see that that's essentially a full halo. Now it's a weak full halo, but it's a full halo, which if we go back, if I pause it right at the time that we see this big smoke ring all the way around. Okay, hopefully you can see that smoke ring all the way around. See that smoke ring all the way around? If I can get my head out of the way. See that? So that's the smoke ring all the way around from the side view. Okay, so you can get this ring. Oh, my hand in the right place. Come on, over here. Okay, that's that smoke ring from the side. This is what the smoke ring looks like if you're head on. Got it? Hopefully that makes sense. So that's the structure that we believe is coming toward Earth. But who believes it's coming toward Earth? Well, NASA does. So if any of you, whoops, let me stand on this side. Anybody of you are familiar with the prediction models? So this is NASA's version of Enlil. We're looking down at the sun from the North Pole. Earth is off to the right. And we're looking at the density of this structure. You can see that structure coming off, right? Hitting Earth. Boom. Right, and even if you look at it from the north-south, the meridional cut or meridional cut, depending upon how you want to talk about it, you can still see that structure, and it looks like it's slightly off to the north, but still pretty well centered at Earth. Okay, so this was what NASA would consider a direct hit. Okay, and that hit, I'm sorry, I can't stop it. I can't freeze this thing, but the hit is supposed to be early on the 27th, late on the 26th, and early on the 27th. But remember, this is supposed to be a wispy structure. Well, from Stereo's view, it's not that wispy. Okay, it is, but it's not. I mean, that's got a little bit of moxie to it. From Earth's perspective, it's a bit more wispy. I have to admit, it's a bit more wispy. So is it going to be a really wispy blow, or is it going to be something intense? Really hard to say, because this, for those of you who are in the know, coronagraphs only look at what we call electron density, Thomson scattering from electron density. That means it's looking at the plasma, the material. Plasma in the material doesn't tell you how intense the magnetic field is that's embedded in that structure. So we're flying blind, sadly. So have there been cases where you have very wispy material and very strong magnetic field? Yes. Yes, we've seen it multiple times. And then they end up they almost become classified as a stealth CME, only because we think it's so wispy that we just kind of poo-poo it as being no big deal, which is what the Space Weather Prediction Center does regarding this event. And then it causes a big geomagnetic storm, a big storm at Earth, and that's a bad thing. So this is one of those things where I'm a little bit kind of like, is it going to be a big structure and a big hit impact or not? It's really hard to tell. So that's NASA, so from NASA's perspective, and I will stop and take questions in a minute, guys. I will, I promise. But from NASA's perspective, this is going to be a direct hit. Okay. But NASA's not the only player. Obviously, the main player, well, no, I'll get to that in a sec. Another player that's recently come to the fore is the Mosswalk. So here is the Mosswalk's run of Enlil. Once again, you're looking at the sun's north pole, from the north pole with Earth off to the right. Okay. And in this case, this is the density panel. This is the velocity panel, so the speed of the structure. Let's just focus on density, because that's all that shows it the best. And you can see that structure coming off. They do believe it's going to be going straight toward Earth, right, and being a direct hit. You can see some of the other structures. Remember, I told you there are structures coming off to the west, or structures coming off to the east. So the Mosswalk has modeled, those structures in this particular run, along with this direct hit structure. Now, if I go to the timeline here, you can see, if I get out of the way, you can see that big bloop up here in green. Okay, that is where the solar storm hits. Okay, this is a density that goes way up. Okay, these models, just so you know, these models are not that realistic. They don't have any magnetic field in them. Magnetic field is just kind of dragged along for the ride. And the reason why is because we just can't run these models faster than real time if we add magnetic field and more realistic and have more realistic physics involved. We have to really dumb down models and make certain assumptions in order to get them to be faster than real time and actually give us predictions. So it's not, it's just the best we can do in the operational world right now. So according to the Mosswalk and their run, we do have a direct hit from that solar storm, but that hit now is halfway to the midday on the 27th, at least. Okay, so we go from the end of the 26th to midday on the 27th. So at best, those two agencies are off by half a day, 12 hours. Okay, and now let's go to our official Space Weather Prediction Center. Right, this is the one. These are the veterans of the whole thing. They've been at it the longest. What do they have to say? Well, here's the fun. In this case, they have two storms coming off to the sun's east, or to the east of Earth. Do you see that? You don't really even see a storm coming off directly to Earth. Now, there is, you may not be able to see it. I wonder if I can make it big enough. Can I make it big? I can only make it that big. And I can't stop it, so I do apologize. But there is a storm. If we wait for it to reset, there is a storm right ahead of that one that's coming out. Do you see this little wispy thing right there that's coming out? Maybe I can follow it with my mouse when it resets. Let me show you. So hopefully you guys can see this mouse. And when it resets, here we go, ready? I'll follow it with my mouse. So there's the other one, and here's this structure. Do you guys see this structure coming out? This little light wispy thing right there. It is so wispy. It doesn't even show up as a blip in the velocity part of the profile. It is like, I don't even know why they bothered to put it in, but it's right here. If I follow it again with the mouse, it's right there. It's going to be hitting Earth. I'm not even sure I can tell, but for the most part, it's completely worthless. It's not even worth mentioning. It looks like their timing is for that structure is right there. So about 16 to 1800 hours on the 26th. So even earlier than NASA. But because it's so wispy, who cares? So we have 3 different official predictions from 3 different agencies, NASA, the Met Office UK, and the Space Weather Prediction Center at NOAA, and none of them agree. Yikes. Is this going to be a fun solar cycle or what? That's what we're dealing with right now. And to be totally honest, in this case, I think Swipsy's wrong because of the halos, right? Because we saw in the stereo, I took a lot of time focusing on that smoke ring, both in stereo and in the LASCO imagery. I think there's going to be a direct hit. I think NASA and the Mosswalk both have a good read on this. How intense this structure is going to be, I don't know. But I would say let's maybe cut the difference between the two. So you'll see in my 5-day forecast that I have this structure, this structure hitting pretty much around the 27th. But I think that you could get any type of hit from late on the 26th into possibly even the 28th. So it may be the very first time where I actually believe that the Mosswalk might have a better read than even NASA does. Do I think that that's going to be the case every time? No, I don't. But this is the state of affairs with space weather prediction. And so depending upon whether you go to, if you're a UK person and you go to the Mosswalk and the Met Office for your solar storm, forecasting, or you are an American and you go to the Space Weather Prediction Center, or, you go anywhere else. And a lot of people use NASA's predictions as well. Pretty soon we're going to have a South African Space Weather Center, and they're probably going to have their own models. And who knows if the Australians, I haven't looked to see if the Australian Meteorological Bureau is using a different forecast. But this kind of thing is going to become much more common. And I'm sorry to say, but as we get this many structures coming up all the time, because the sun, when we get to solar maximum, is going to be launching on average about 8 CMEs a day when we get to solar max. This kind of thing is going to become a bigger and bigger problem. So hopefully before you tear your hair out, get mad and write your congressman, or rather, write your congressman and say they need more money. But before you get mad and write the forecasters who are trying to do their best with these predictions and tell them how horrible they are, please understand it's tough. It's really tough. We have very limited observations, and they're squishing 3-dimensional objects into 2 dimensions, and we have stuff overlaid and on top of each other, and it just drives us nuts. As a matter of fact, I can show you, if I get away from this one and focus for a second on the 24th. Look how ugly this gets. So let it load. And while this plays, well, it's loading slowly. Come on. So here's that structure. Whoops, if I can get out of the way. Here's that structure that goes off to the west on the 24th, along with you'll see the structure that goes to the east as well. That's the snot nose structure that goes off to the east that you'll see in just a second. But once it starts playing in better speed instead of just loading up, you'll see that there are multiple structures here that are overlaid on top of each other. There we go. So you see structures that are blowing slowly. There's a fast one, and there's a fast one to the east. And then look at the slower one to the west. and you see stuff overlaid on top. Can you tell that there are multiple structures going off and that there's three-dimensional objects being compressed into 2 dimensions? It's very plain, especially in the west limb, because you can see that big structure going off and you can see that slower structure underneath it. So here's the big structure that goes off and then the slower structure that goes underneath it. So you can see that there's just, it's really, really tough. And automated algorithms really fail in situations like this. So we're going to start seeing a lot more of that issue. And so you have to have scientists in the loop that can pull apart these things and see through the patterns to be able to make better predictions. But they're definitely not going to be foolproof. So that's really the state of things right now and why you're getting so many predictions that are different. So with that, I don't know if I'm going to, yeah, I'm just going to go to the 5-day outlooks. Let me just do that now. I want to see what, yeah, I've got very few minutes left. Oh my gosh, I may not be able to take any questions. So for our solar storm predictions, as you can see, I'm not, I've got a lot of asterisks. These are my predictions. Anytime you see the asterisks on there, that tells you that I'm changing the predictions from NOAA's. So I do believe at high latitudes, we're going to be seeing some 9er storming easily over the next 3 days at least, with up to about a 55% chance of major storming. And that's at high latitudes. At mid latitudes, if we're going to see any active conditions, it's most likely going to be on the 28th. But we do have probably about a 30% chance of minor storming, maybe starting on the 27th. So be aware of that. And that was all because of these solar storms that are hitting. It's a pretty crazy bag right now, but that's what we're going to be seeing. And things should settle down reasonably quickly after that, because we're not going to be getting a lot after that, at least for the rest of the week. And so aurora photographers definitely, you know, there's definitely a good chance that you can get some aurora down at mid latitudes, but definitely high latitudes will see a lot. Now, for the solar particle or the solar flare and particle radiation storm outlook, the M-class 5% M-class or chance of M-class flares is really from region 2860 now. It was from 2859 last week, but 2859 looks like it's kind of calming down. So we're definitely just watching 2860, and we may have a new region rotating or emerging. And if so, that M-class flare risk may go up a little bit, but I doubt it. I think it'll probably stay around 5%, probably for this entire week, as long as these regions are in Earth view. Meanwhile, the solar flux is climbing up. We've got it up to the 86 at least by the end of the week. That could go even higher, especially if these other regions begin to emerge even more. So I'm going to pay attention to that. And also, I'm almost about to change the D2 minor range down to a D1. I've been watching the cosmic ray flux. It's really dropping. So that's a really good sign. So we may be, because as that cosmic ray flux drops, that really tells us the solar cycle 25 is taking off and the sun's magnetic field is really strengthening. So that's really a good scene. And anyway, that's the end of that. And for the last few minutes, I'll take some questions if you guys have them. Hopefully this was more clear than mud. So the sun looks like a big pizza. Yeah, give me just a couple seconds. Well, it said 5:55.
5:58.
Oh, is it? Okay.
Okay.
I'm going to end up being kicked off. Can you believe that? So for all of you, I'm sorry I wasn't able to answer questions. The studio has to be used by my husband doing his comedy stuff for LA Connection. So I'll answer one question. I got Chris right here. Do you recommend staying indoors on those days? No, don't worry about it, guys. These storms aren't all that intense. So for those of you in my Patreon community, go ahead and give me questions on that post, and I will get back to you. I promise. And we'll do this again sometime. Okay. So hopefully you guys enjoyed this, and don't worry about the solar storms. They're not going to be too intense, but we could see some aurora over the next few days. Okay. Bye.